Alrighty, so here we have comparing unit rates. You're shopping for t-shirts. Which store offers the best deal? Remember, unit rates is the fraction with the denominator of 1, so oftentimes you'll have to divide. Store A, $25 for 2 shirts. Store B, $45 for 4 shirts. And Store C, $30 for 3 shirts. Now, again, I always say we're in America, money's important, right? Dollars on top, though, because it makes sense to us. You could do shirts per dollar, but then you have to think about getting more or getting less instead of more, right? So, again, 25 divided by 2, so dollars on top, that's $12.50 for 1 shirt. $45 for 4 shirts, that's $11.25 for 1 shirt. Again, all I'm doing is dividing. 45 divided by 4. $30 for 3 shirts, that's $10 per shirt. The best deal is obviously Store C, the cheapest price, $10 for 1 shirt. Now, if, by the way, Store B lowered this price to $42 for 4 shirts, does the solution problem 1 change? So in other words, we're going to have $42 for 4 shirts. Again, a little division fun here. And that becomes $10.50 per 1 shirt. So obviously C is still the best deal. I should say at the outset you'll need some additional information for these conversion factors, and I have included those in Schoology for you inside of the 2-6 folder. I have 2 different sheets of conversions that I've included in there, so those are available for you anytime you need them. Alrighty, so let's get started on this. It says, what is the given amount converted in the given units? Choose and multiply by the appropriate conversion factor. The appropriate factor will allow you to divide out the common units and simplify. So this is that whole unit analysis piece. So if I want to convert 330 minutes into hours, that's 330 minutes. And so the way I would write this, let's just kind of make that part clear. I would write 330 minutes, I promise that's minutes, over 1. And I want to convert minutes to hours. So minutes goes down, hours goes up, because again we're going to cross cancel diagonal. So minutes, left with hours. That's what I wanted, so that's what I'm shooting for here. Hours. Now you put in the numbers. 60 minutes and 1 hour. So what that really yields, if you multiply straight across, is 330 over 60, which again we're going to want to go ahead and divide that out. And we will get 5.5 hours. And that's the way that's done. Similarly, if we continue with B, 15 kilograms to grams, again, I would have written it with the 1 here, right? And we can see we multiply straight across, so we're going to get 1,000 over 1. Again, that unit analysis piece lets you cancel diagonal, so you get rid of the kilograms and have just grams. So we have 15 times 1,000, or 15,000 grams. And then inches to feet. Again, we've obviously done one like this. But again, that 15 foot 3 inches rather. So you're going to end up adding that 3 on the end. So save that. So you need 5 feet into inches. So feet down, inches up. And again, unit analysis yields just inches like we're looking for. And there are 12 inches in a foot. So 5 times 12 is 60. Don't forget to add back on that 3 for a 63 inches there. Alright, so you get to do the got it and pause and come back here. And hopefully you found the answer to be 12.5. Oops, grabbed the wrong thing. There we go. So what we're looking at here is 1250 centimeters over 1. And centimeters goes down because I want to cancel and to turn into meters. Again, that unit analysis piece left with just meters. Now I plug in the numbers because I know that the letters work, right? There are 100 centimeters in a meter. So it's 1250 divided by 100, or 12.5 meters. Alrighty, so converting between systems. So here we're going to go feet to meters, right? So the CNN Tower in Toronto, Canada is about 1,815 feet tall. But how many meters tall is the tower? Use this fact that 1 meter is 3.28 feet. And again, I always like to put over 1 here, so 1815 over 1, so that their fractions line up. And again, we're going to go feet down, meters up. That's what I'm shooting for, is meters. And so we end up multiplying straight across. I'm just going to cross this stuff out. We have 1815 over 1, and again 1 meter over 3.28 feet. And so really, in the end, we're going to have 1815 over 3.28, and you have to divide that out. And we find that it's about 553, and again our label there is going to be meters, so 553 meters. And again, is that a reasonable answer? Well, again, you can obviously check that as the discussion goes here. So you divide, again, 1800, right, by about 3, so 600 seems, so that's pretty close. So again, a reasonable answer, always a good idea whether to check that. Not a bad idea, that's what I was trying to spit out. So your third got it here. We have a building this time 1450 feet tall. And we want to convert that into meters. So again, feet has to go down, meters up. Because feet cancel, leaving with just meters. And again, we know there's about 3.28 feet in a meter. So what I'm really going to do is 1450 over meters over 3.28. And you go ahead and divide that out. And you get 442.07, so about 442 meters. Alrighty, B, a monetary exchange rate changes from day to day. On a particular day, the exchange rate for dollars to euros was about $1 to 0.63 euros. Alrighty, so again, dollars is going to go on top. We're going to start out with $325 over 1. And we're going to put dollars down and euros up. And we know $1 is about 0.63 euros, it says. Multiplying straight across. So again, double check your unit analysis. The dollars cancels out. And we're left with just euros. I think that's a symbol close enough for euros, right? 325 times 0.63 is 204.75 euros, or about 205 euros. Alrighty, so on this one, a student ran 50-yard dash in 5.8 seconds. At what speed did the student run in miles per hour? Round your answer to the nearest tenth. So, again, we start with 50 yards, 5.8 seconds. It's exactly what we know. We have to convert yards into miles. So yards goes down, miles goes up. So there are 1760 yards in a mile. Seconds into hours, 5.8 seconds, and again there are 3600 seconds in an hour. Again, you can double check with that unit analysis piece. Yards goes away, I'm left with miles. Seconds goes away, I'm left with hours. And I was shooting for miles per hour, so obviously it's right. That's when you just go back and fill in the numbers. Again, 1760 yards in a mile, 3,600 seconds in an hour. And in this one, we're going to multiply, as you can see here, straight across. So we end up with, on the top, 50 times 1 times 3,600, which is 180,000. And on the bottom, 5.8 times 1760, which is 10,208. And you're going to divide that out, 17.6 miles per hour. Okay, so we're going to do something similar here. So an athlete ran a sprint 100 feet in 3.1 seconds. So it starts out this way, 100 feet, it's feet I promise, in 3.1 seconds. So I'm going to want to convert two things. Feet into, I want to know miles per hour, yes. So feet into miles. So again, to get rid of them, feet have to go down, miles up. Then we're going to convert seconds into hours. Seconds has to go up, so it's diagonal to hours. Now, let's double check our units. Feet, miles, seconds, hours. So I'm left with miles over hour, which is what I was shooting for. Miles per hour. Now I can fill in the numbers. There are 5,280 feet in a mile. There are 3,600 seconds in an hour. So in the top we're going to have 100 times 3,600, which is 360000. And the bottom 3.1 times 5,280, which is 16368. There we are. Divide that out and we get 21.99, or again about 22 miles per hour. And if we take a look here, it says in problem 4, one student multiplied by the conversion factor 1 mile over 7,680 yards in 60 seconds in a minute, and then 60 minutes in an hour, which is absolutely fine. But again, because notice, I did straight seconds to hours. I could have easily broken that up. Now watch this one. I could have easily broken that up into seconds per hour, and then, or seconds per minute, I'm sorry. Let's erase that there. Seconds per minute, and then minutes per hour. So my seconds went away because they were down here, so seconds, minutes, minutes, still left with hours in the bottom when you run the unit analysis. All right, there you go. Make sure you're asking questions, folks, if you're struggling with this at all.